In this video, we will practice using the chain rule, which allows us to take the derivative of a function inside of a function. If you appreciate the content, please give it a like. The chain rule says when you have a function inside of another function, to take the derivative, you start by taking the derivative of the outer function. The derivative of tangent x is secant squared x. So we start with secant squared parentheses. So we've taken the derivative of the outer function. At this step, we leave the inner function alone. But then the chain rule says that you multiply by the derivative of the inner function. I'm thinking of 1 over x as x to the negative 1 power, so I can now do the power rule to take the derivative. So that negative 1 comes in the front. I reduce the exponent by 1. And this is the derivative. On a free response question, you're allowed to leave your answer like this. However, on a multiple choice question, you would more likely see it rewritten like this. The x to the negative 2 power drops down to the denominator as x squared, and usually the negative sign will be in the front. Pause the video and try this one on your own. I'm going to assume that you did that. Let's rewrite this before taking the derivative. This is equivalent to, in fact, let me colorize it as I go along. We have 4x squared as the inner function, and then we are raising the whole thing to the 1/3 power as the outer function. So according to the chain rule, if we want to take the derivative, we start by taking the derivative of the outer function, the blue part. So we put that 1/3 in the front, and we reduce the exponent by 1. 1/3 minus 1 is like 1/3 minus 3 over 3. So that's negative 2 over 3. So we've taken the derivative of the outer function. As you do that, you leave the inner function alone, but then you multiply by the derivative of the inner function. Using the power rule, that is 8x. So that is the final answer. Also, be able to recognize this as the answer on a multiple choice question. The negative 2/3 power drops this portion of the answer down to the denominator. The second derivative is the derivative of the derivative. So let's use the chain rule to take the derivative twice. When you put an exponent in the middle of a trig function like this, it means the entire function is raised to that power. So this is really a function inside of a function inside of another function. So there's a lot of chain rule to do. The chain rule says that first we take the derivative of the outermost function, which is the blue layer. So I'm going to put the 2 in the front, and we've taken the derivative of the outermost function. When you take the derivative of an outer function, you leave the inner function alone. And then you multiply by the derivative of the inner function. So we need to take the derivative of the sine of 3x, which will again require the chain rule. So again, we take the derivative of the outer function, which is now sine x. The derivative of sine x is cosine x. So with that, we have taken the derivative of the outer function. And when we do that, we leave the inner function the same. Then finally, we multiply by the derivative of the inner function, which is 3. So this is the first derivative. We need to take the derivative again to make the second derivative, but I think I will clean this up a tiny bit by multiplying the 2 and the 3. So the first derivative is 6 times the sine of 3x times the cosine of 3x. The second derivative is written as f double prime. To find it, we take the derivative of f prime. However, f prime is actually the product of two functions, so we're going to have to find the derivative using the product rule. According to the product rule, you sort of go through twice. The first time through, you take the derivative of the first function, the yellow function. When there's a constant in the front, you just bring that constant down and you move on to whatever's next. The derivative of sine 3x will require the chain rule. Starting with the derivative of sine, which is cosine. So we've taken the derivative of the outer function. At this stage, you leave the inner function the same. But then you multiply by the derivative of the inner function, which is 3. So what you see here is the derivative of the yellow function. The first time through the product rule, you leave the second function alone. So I'm going to bring down the cosine of 3x. And then you put a plus and you go through it again. The second time through, you leave the first function alone. So I'm just going to bring down the 6 sine 3x. But then you multiply by the derivative of the second function, which will again require the chain rule. So as I take the derivative of cosine 3x, I start with the outer function, which is cosine. The derivative of cosine x is negative sine x. I do not want you to do this and put negative sine 3x like that. The problem is if you put the negative sign right here, students will often sort of forget that this was a multiplication problem, and they will accidentally treat this as subtraction, and then everything comes out wrong. So whenever you are multiplying by something that is negative, I want you to take that negative sign and put it in the front. So here's your negative sine 3x. We've taken the derivative of the outer function. Now we multiply by the derivative of the inner function, which is 3. If this is a free response question on a test, I want you to leave your answer just like this. This is the second derivative. I can barely fit it on the screen. Do not risk making a mistake in the simplification process. However, we're just practicing and we need to prepare for a potential multiple choice question. So let's do simplify a little bit. For example, the 6 times 3 is going to make 18. So we have 18 cosine. Oh, also we have 2 of these. Cosine 3x times cosine 3x is cosine squared 3x. All right, what can be simplified in the next term? Similarly, we have the 6 and the 3, so we're going to have minus 18. And again, we have 2 of these. Sine 3x and another sine 3x is sine squared 3x. So that did simplify quite nicely. So on a multiple choice question, this is most likely what you would see for the second derivative. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.